everybody. We're going to go over the radicals quiz that we gave in class on Friday and go over any questions that you have. This covers pretty much everything you need to know in Chapter 11 for the final, so make sure you study this as much as possible. There's a lot of ways you can do this. The easiest way is to find the square root, the biggest square root possible that goes into 48. Anybody know? What's the biggest square? Well, first of all, what are our square roots? We got 1,
16 and 30.
4, 16, 25, 36. Give me some more, guys. 49, 64, 81, 100. Because these are perfect squares, because this equals 1 squared,
121.
equals 2 squared, that's right. 4 squared, equals 5 squared, equals 6 squared, equals 7 squared, equals 8 squared,
He got
equals
9.
9 squared, equals 10 squared, etc. Guys, you need to know these, because why? Because you'll recognize right away how this works. We can see, oh, 48, it breaks down into root 3. And the root of 16 is equal to 4 root 3. And we're done. That's the final answer. And see how easy that is if you know your perfect squares?
Yeah.
It's a lot easier. Now, I'm not saying that's the only way to get this answer. I mean, there are other ways. I can go root of 48 equals the root of 6 times the root of 8. Most people broke it down that way. Okay, that's okay, but you're not done until you break it and break it and break it down. So, root 3, root 2, root 4, root 2. Okay, no problem. Oh, there's a perfect square. Okay, that helps. And these are doubles, so I'm going to take my perfect square over here to the left. I'm going to put my doubles together. And then my root 3 I'm going to put over on the right because I can't break that down anymore. It's not a perfect square and there are no doubles. Root of 4 is equal to 2. The root of 2 times the root of 2 is equal to 2. And when it comes out of the radical sign, it gets multiplied. And I'm left with root 3 on its own. It can't go anywhere. It can't do anything. And it's equal to 4 root 3, which is the same thing. But, well, what one was shorter? What was more elegant? What was the easier one?
The left.
The left. Yeah, that one right here. My right, your left. That was fine. It just took longer. And you have to go through all of this stuff to get there. It's okay. Look, this is instructional for sure. Because you have to realize when you get a perfect square, you put it on the left. When you get doubles, you put them together. When you get anything that can't be rooted, it goes on the right. And then you end it up there. Okay? So any questions on that? That's number 1. And this is number 2 on our quiz. The square root of 12 n squared. On this one, you can again do it different ways, but the best thing is to find a perfect square that goes into 12. And you can separate the 12 from the n squared. So we're going to go the root of 12 times the root of n squared. Most people know that pretty intuitively because this is a different thing than the number. This is equal to root 4 root 3 root n squared, and that is 2 root 3. Now, n, because the root of n squared is equal to n. Some people, which can be written as 2n root 3. There's, again, the high road, the low road, whatever you want to do it. Here's the way it goes. The root of x squared equals x. The root of x to the 4th equals x squared. The root of x to the 6th equals x cubed. Why? Because if this is x squared, okay, equals the root of x squared squared. Well, that comes up because 2 times 2 is there. That equals x squared, okay, because we have 2 of them, so it's the square root of that. It's like saying the square root of 25 is equal to the square root of 5 squared, and therefore it's equal to 5. Okay, the square root of anything squared is the original. Okay, if I took the square root of x squared, it would be equal to x. Now this isn't doubles, this is because the square root of something is the inverse operation of the square of something. A square makes it bigger. Okay, let's take any number, any old number. Let's take 10. If I square 10, does it get bigger or smaller? It becomes 100. So how do I shrink it back down to size? Yeah, okay, but what do I do to get? Put a radical. The square root of 100 brings it back down to size. And we started with 10, okay? We squared it. And then we took the radical to it, we square rooted it, I guess you could say, and then that equals 10. So do you see how the squaring of number and taking the square root of a number are inverse operations? Does that make some sense? That's what happens. It's the same principle here. The square root of x to the 4th because x to the fourth is x squared squared, you're basically saying the square root of x squared squared is equal to x squared. We're taking the inverse operations. Same idea here, because this is equal to the square root of x cubed squared. So it's equal to x cubed. That's the kind of the full explanation of this. Every time you use this, you don't think about all that. To use this, okay, just to use it, all you really need to know is this simple pattern and what's the square root of x to the 8th. Anybody out there, Caroline? What's the square root of x to the 8th?
X to the 4th.
Right. You see the pattern, guys? What's the square root of x to the 10th?
And X to the 5th.
X to the 5th. Everybody probably sees that pattern, right? Well, what happens if we go like this? What's the square root of x to the 13th? Is it so simple now? What happened to our pattern? We don't have an even exponent, do we? So what do we do to get an even exponent?
12.
Yes, we break this down into the square root of x to the 12th times the square root of x. Okay? That makes sense?
Mm-hmm.
And the square root of x to the 12th is easy, right? It's equal to?
X to the 6th.
Good. And with the square root of x, can't do anything with it. That's as low as we can go. So that's the pattern. Whenever you get an odd exponent, it's always going to be something root x. Something root x. Okay? Because it's always broken down into an even exponent and an odd exponent. Questions? In that case, see how we got the root of n squared? The root of n squared is equal to n, 2n times 3. Simply 2 times n over here. You always bring all of the things that are no longer in the radical sign, go over to the left. Anything goes under the radical sign goes to the right under the radical. Okay. Okay, so this is the root of 2a times the root of 8a. Root 2a times root 8a. We break it down. What else could we do? Break it down. That's the whole name of the game here, is breaking stuff down. Root 4 times root 2a. Oh, why did I break it that way? Because of doubles, root 4. I'm going to put the root 4, the perfect square over here. I'm going to put the root 2a, the doubles here, and I'm going to get 2 times 2a. Why 2? Because the root 4 is equal to 2. You got to know your square roots. And root 2a times root 2a, because whatever it is, if it's a double, it's that. It's whatever it is. 4a, done. That problem is over. Click. Number 4, negative 6 square root 5x cubed times the root of 10x. Okay? So getting more complicated and all that, but what's the difference? Nothing. You just break it down. Every time you break it down, just keep breaking stuff down. That's the name of the game in this chapter, is break it down. So, how do we break it down? Negative 6 onto root 5, root x squared, root x. Why? Because even exponent. Okay? Root 10 can be broken down into root 5, root 2, root x. What do I got? I've got square root of x squared, which is equal to x. I've got doubles, and I've got the square root of x times the square root of x. For those who like pretty colors, I'm just going to check that off. And in red, I'm going to put, look at that. And this right here, I'm going to put this as a triangle, only to delineate the fact that I've got certain groupings of things. So now let's group them together. Negative 6. We've got the root of x squared, which is x. I'm going to put it over there. Why? Because anything that's not in a radical sign anymore, I put on the left. We've got root 5 times root 5. We've got root x times root x. And we have poor, lonely root 2, who's going to get stuck inside the radical house forever and ever. Negative 6x times 5, or at least till the end of this problem, okay? Times root 2, just put negative 30x squared root 2. Yes, Tara?
Where did you get 6x from?
6x, well, we got the root of x squared, which is x, and then we brought it over here to 6x. So if I were to draw another line in here, I could go negative 6 root 5 times x times root x, okay, times root 5, root 2, root x. So then I just chose to put the negative 6 and the x together. Why? Because they're not in the radical sign anymore. So I move them over to the left.